look at the question here, everybody. So, when boating on a windy day, quiet down, please. Keep it down, please. You may encounter some waves that are bigger than others. Any guesses as to why that might be?
Because the wake of the other boats.
Could be other boats. You're actually going to see these waves get pretty big, even if there aren't any other boats on the lake.
Wind affecting the waves.
Yeah, because of wind. And I'll give you the one-word answer right now, and then I'll kind of explain it as we go forward. The one-word answer is interference. Interference.
Oh, because the waves combine.
You got it. Storm winds do not just blow in one direction. They blow in all sorts of different swirly directions. And so you've got waves moving in all sorts of different paths. And when those waves can combine, you end up with some waves that are much larger than the ones you might have just began with. I'm just going to tell you a quick story before I show you an example of this. I was just a kid, and my dad and I went out on his little 10 or 15-foot aluminum boat out to the lake. And all of a sudden while we were out there, it was a nice day, and all of these black clouds just came out of nowhere. And the wind really started to pick up. We started to head back to our house, and we didn't get there in time. We were still on the lake when there were tons and tons of really large waves that were out there. And I'm never going to forget one of the waves. I was sitting on the front of the boat, and again, this is an aluminum boat with metal seats. And so I was on the front of the boat, my dad was on the back controlling the motor, and I looked back, and we went over a wave that was so big that I could actually see the motor spinning around, the propeller. I know, it's crazy. And, you know, when you have a wave that big and you come down that hard, I tell you, my butt didn't feel the same for about 2 weeks. And, you know, the question is, how is it that you can actually see the back of a propeller when you're out on the lake? Not all the waves are that big, only a couple of them. And it almost sounds like it's just fiction. But I'm going to show you exactly what was happening under those conditions. Like I mentioned, when you have waves that are being produced during a storm, they're produced by the wind. And the wind swirls all over the place. And so when you've got wind blowing all over the place, you've got waves going all over. And that's what's going to be represented on the screen here. So first off, we've got these waves. These would be like typical waves being produced by wind or something. And you can see that they have a certain amplitude. They have a certain height to them. Now, what I've done in this simulation is I've added a wall that goes all the way around. So these waves are going to bounce off that wall, and they're going to start hitting each other. And you can start to see what happens when they hit each other, because that represents when waves are blowing wind, when wind is blowing waves in all different directions towards each other. Check it out. Yeah. And so as that wind is blowing those waves in all different directions, and they start interacting with each other, when they start interfering with each other, all of a sudden you've got a condition where these waves are way taller than anything you began with. If I would just pause this at a time, I mean, just look at the heights of these waves. And when you have waves that are this tall, you've got crests that are just that high going down. And that's why I was able to see the propeller spinning on the back of my dad's little aluminum boat. Not because we went over a giant wave crest, but because behind it was a very large wave trough. So it goes both ways. And it's just as a reminder, remember how big these waves are here. These are the waves that we began with. From those small waves, just using interference and the principle of superposition, where the waves just add to each other, you get that massive amount of wave amplitude, conditions like that. So, speaking of interference, that is what we're going to be taking some notes on today. But we should just not take notes today, and that's actually a pretty good idea. And the reason for that is because in the past, when I had students taking notes on interference, if you don't do it just right, it can actually cause more harm than good.
So you did the notes for us.
So, yeah, basically I just made copies of what I look at for this when I'm making the notes. And I'm just going to explain a couple things, and you'll have probably 20 minutes to get to work on the homework, which won't even be due until Thursday. So I'm going to go ahead and pass out the notes for you. Now, there's two kinds of interference. There's constructive and there's destructive. Which one do you suppose is the one where two crests come together and you got a big, big, big wave? Constructive. What about if you have two troughs coming together and you got a big, big, big trough?
Destructive.
That one's also constructive, actually. Whenever you've got two waves that combine to create a bigger wave, whether it's a bigger crest or a bigger trough, we call that constructive interference. And that's the very first thing that you'll see on this note sheet that you get. So just kind of going down from the top, the notes are on interference. Interference is when two waves interact, and of course the other thing that we did when two waves interact is the principle of superposition. When you've got two waves that come and they interact with each other, the result is just a sum of their combined shapes. So if you've got a 3-foot wave and a 3-foot wave and they meet, you're going to have a 6-foot wave. And not just a 6-foot high crest, you're going to have a 6-foot high trough. And so, yeah, so when you have interference, it's not just doubling. You're basically quadrupling these heights because it goes both ways. That's what makes these waves so deadly. So the next...
swimming in one of those.
That'd be kind of fun. Do you guys like swimming in wave pools?
Yeah.
Yeah, me too.
Especially like in the dells, like the big wave pool things.
Oh, yeah.
There was one time when I was like 10 where we were at Dells, and basically, so I was left unsupervised for about 5 minutes, and I went in the wave pool, and I almost drowned, and they had to like stop the whole thing. The guy blew his whistle, and it got really embarrassing.
Well, we're glad you're here, and the alternative would be that you're not here. And so it turned out pretty good for you, I'd say. Did they get you right away, or did they notice that you were having trouble right away, or did it take them a while?
I was like kind of struggling for like a good 30 seconds.
Okay.
I mean, I was fine. I wasn't drowning. But like, they thought I was drowning, and they had to like stop everything. It was really embarrassing.
Okay. Well, that happens. It happens to the best of us. I always liked wave pools because I always kind of felt like I was jumping on the moon. Because, you're on the ground and then the nice big one comes and you just jump with it and then you land. That's fun. Okay. So destructive interference is when you have one crest and one trough coming together. That's also known as a minimum. You basically have something where those two are canceling each other out. Then the biggest part of this whole thing has to do with maximum lines and minimum lines. And in order to discuss that, I just want to point out a couple spots on this. And you'll see there's a couple locations on the notes where I put little dots. Let's say we're looking at this dot right here. So on this picture, we've got all these lines. What do you suppose these lines represent?
Wave.
What part of a wave?
No.
It's on your notes.
Interference.
Nope. Crests, yes. Each line represents a crest. And so if I'm in this location, I've got two crests in the same place. Therefore, that is what kind of interference? Constructive interference. What if I go maybe this location right here?
You got 4. 4, no.
It's a crap.
Could be.
Wouldn't it be
There ain't no troughs in this picture.
Oh, sure there are. Between the crests, you've got a trough.
Oh.
So like for this one,
So that's,
we've got a crest here
it's still
and a crest there.
it's constructive.
So, yep, it is.
Because
So
it's
we've got a
two
trough
troughs.
there, and we're in between these two crests too. So this location would have two troughs in it. That would be also known as constructive
So
interference.
that would be like a double. Big one.
How?
Yeah.
I don't. Where
What's
are
that?
the troughs? Why? Where?
Troughs are exactly between crests.
That doesn't even make sense. Oh no, yeah.
So this spot is between these two crests, and it's between these two. So you've got two troughs in that location.
So you're like way down.
How about this location right here?
That's deep.
That is destructive interference because we have a crest represented by the line, and it's exactly between these two crests. So you've got a crest and you've got a trough in that spot. That is destructive interference. Questions on how that works? No. Okay. The rest of these notes are going to be on maximum and minimum lines. And you can see that described a little bit in your notes. I'll just show you exactly how it works here. All you do to draw a maximum line is you line up a straight edge with spots where you have crests intersecting. So like there's a crest here, and here, and here, and here. And once you know it, when you line all those up, they form a nice, beautiful straight line. So all you do is use a straight edge, and you make a line go straight through them all.
Oh, so it's from the first one down.
Yep. And that's called a maximum line. And you can do that to the left and to the right of this location as well. So if I look, these are all kind of lining up. That would be another maximum line. If I look to the right, they're kind of lining up in a straight line right there. So that's another maximum line. And I'll go one more over to the left. Those three are in a straight line. So that would be another maximum line. And you could extend those as far as you want. All you're doing when you draw maximum lines is you're lining up the spots where the crests are all intersecting. You can kind of see how this would be hard to actually take notes on. You'd have to draw these two waves exactly perfectly. So we also have labels for these maximum lines. This middle one that goes right down the middle is the 0th order maximum line.
First and second.
You got it. Next one over is the first, and then this is also the first. And then you got the second, and you would continue on from there. That's how you draw maximum lines. Questions on that?
Is there a minimum line?
There sure are, and they're going to come next year.
In between. Next year?
Nope. Next minute. Minimum lines are exactly in between maximum lines. It is very difficult to actually find the spots right in between the crests and right on the crest in the middle. It's very difficult to try and line up a straight edge with those locations. So here's my advice to you, and I think this is the last thing on the notes. My advice to you is when you're drawing minimum lines, start by lightly drawing in your maximum lines, and then for your minimum lines, just put those exactly in the middle. So that would be a minimum line.
Will we get it marked wrong if we don't get it exactly in the middle?
No.
Okay, good. Mine's gonna be so off.
So where I drew the red things, those are where your minimum lines would be. So then the last step, if you're only supposed to draw minimum lines, is you would want to erase your maximum lines. And the way that we label minimum lines is a little bit different from the maximum lines. Maximum lines, the very middle is the 0th order because it's right in the middle.
0?
Yep. For the minimum lines, there's nothing that's right smack down the middle. And so we start with first order when we're dealing with minimum lines. And it works outward from there. Questions on how that works? Okay. I'm just going to show you number 1 from the worksheet because it just it confuses some people.
Will we get time to work on it?
Yeah, you'll have about 16 minutes to get started on it.
just one page?
No.
2 sides.
Yeah, it's got a lot of pages, actually.
Ah,
But you've got 2 days to work on it, including a lot of this class period.
we get tomorrow too?
Well, tomorrow's going to be a special day. We call it a Mythbusters Day.
Oh yeah.
So, at least you're not going to be doing anything in class that adds to your workload. So, for number 1, it just says these are the intersections of the 2 crests. Sketch the position of the 2 crests a short time later and indicate the direction of the movement. All this is asking for is, if these waves are moving outwards like the arrows indicate, that means after a little while this wave will be right about there. And this wave, also moving outward, will look something like this. And then it says, indicate the direction of the movement of the intersection. Well, the intersection has gone from there to there. So it's moved up. That's all you need to do for number 1.
Oh.
Other than that, it's mostly drawing those straight lines. So I'll get that passed out.